In this lesson, we'll be talking about the vertical line test as well as the horizontal line test. So, we must know what is a function. A function is a graph in which the vertical line cuts it once. So, if we draw a vertical line on a function and then the line cuts the graph once, it means it's a function. But if the vertical line cuts the graph 2 times, it's not a function. Let's have an example. A vertical line is a line like this, a line that goes up and down. Okay, so let's have a straight line function like this. Let's draw a vertical line. You see, everywhere it cuts the graph once. This means that this line is a function. Let's have an exponential function. You see, the same thing. It means that it's a function. And then let's have a parabolic function, a parabola. A parabola will look like this. And let's draw a vertical line. A vertical line will be like this. And it cuts the graph once. It means that it's a function. As long as the vertical line cuts the graph once, it means that the graph is a function. But if we have a parabola that is like this, or a graph that is like this, does the vertical line cut the graph once? No. It cuts here and here. This means this is not a function. If something is not a function, it's called a relation. So make sure you understand this. So we used the vertical line to determine whether something, a graph, is a function or not. If it's a function, we want to know what kind of a function it is. Is it a one-to-one or a many-to-one? We use what we call the horizontal line test. Okay, so now we're talking about the horizontal line test. The horizontal line test is used to determine a type of function. So let's say, okay, when we're talking about a type of function, we've got one-to-one or many-to-one. We simply mean how many x values do we have to a specific y value. If we've got one x value to a specific y value, it's called a one-to-one. But if we have got many x values to one y value, it's called a many-to-one. Okay, so let's have a straight line function that is like this. First of all, we use a vertical line. It cuts once, it means it's a function. Okay, so we can agree that it's a function. But want to know what type of function? Then we're going to use a horizontal line. You see? Then check. We have got, let's say you have got the point 1 and 2. For one x value, there is one y value. There's no repeating number. There are no repetitions. There's only one x value and one y value. One x value, one y value. One x value, one y value. So if here the y value is 2, obviously it's going to be 3, obviously it's going to be 4. There's nothing that repeats itself. This means that this is a one-to-one. So we use a vertical line to test if it's a function or not. If it's indeed a function, we want to know what type of a function. Then we use a horizontal line. The horizontal line will tell us the type of function. If we've got one x value to one y value, then it's called a one-to-one function. But let's have a parabola, for instance. We're going to use a vertical line test. It cuts the graph once. This means it is a function, or it's a function. But want to know what type of function. Want to know how many x values to a specific y value. Then we use a horizontal line test. Look, we have one y value, because it's a horizontal line. Let's say we have the line of y is equal to 2. Obviously, if here we have 2, if here the x value is 1, here the x value will be 2. And let's say here the x value, if here the x value will be negative 1, here let's say the x value is 3, the y value will still be 2. You see, we have got two x values, negative 1 and 3, but they share the same y value. So we've got many x values to one y value. So we can say that it's a many-to-one function. First of all, we must know, is it a function or not? If it's a function, then we use the horizontal line test to determine the type of function. If we've got one x value to one y value, then it's a one-to-one function. But if we have got many x values to one y value, then it's called a many-to-one function. Thank you for watching.